Alright, science fans, space fans, absurdity loving fans. I've got a freaking truck coming up the road, so let's wait till he's gone. And what do we see in front of us? A light, right? Okay. Let's go start moving forward. What do we see? Oh, candle. What, didn't you see the candle? And the flame is above its level, right? Now the reason you don't see the candle is because it's not as strong, is it? Look. So nothing to do with the speed, is it? One reaches us and one doesn't. If we zoom in, doesn't even just see it flickering on the right hand side. There it is. Ooh, nearly came into focus, didn't it? There it is. When you're out, when you're looking at the sky, at the stars, you only see the bright ones, ones that are more powerful or the closest. Alright, now I did this not too long ago. And I'm not joking. Right, 6 minutes and 40 seconds. Eight minutes and 20 seconds. Earth's diameter. So I had it worked out on this fence, right? That was where, because I started at the sun, so I went Mercury, Venus was here. So it'll be Mercury. And this was 150 million miles. 1 times 10 to the minus 10 power. Alright. So I'm going to go and take that bulb back over there. I actually meant to leave the bulb over there. So now I have to point this stick. Because I only want to do this once. Zoom into the candle. There it is. Alright, see the candle? There it is. Alright. I'm going to turn the bulb on and off. And it's going to be roughly 108 to 110 diameters. That's what this is about. course there's no delay, is there? Oh look, it's just appearing, look. So, science fans, one in the bookcase. That's not Google, by the way. So, what we saw there was this bulb. Forget the first one. That instantly proved that the most powerful one is obviously visible, where the one that isn't visible is the baby stuff. So it's not about speed. But this, when we did that back then, so I got a little bulb, right? I was about 16, 17 meters. Right? And it was instant. Eyes. Right? It was instant. Tiny bulb, about 6 centimeters. 60 meters. If I move away to make it 160 meters, right, that's times 10, this becomes 10 times the size, right? 10 times more powerful. Am I going to be able to see it from 160 meters now? Right? If it's this size, well, I said 10, that's 1, 2, 3, 4, 5, so twice this size, right? But this is just roughly, all right? So we look at 50, all right? That's 5 and a bit, so say 52. 30, 40. That's going to actually be about here. 10 times the size. Alright, so I'm 160 metres away now. 200 metre running track. I've got this thing. Big round light shining at me. Am I going to see it? Of course I'm going to see it. Boom, we move times 10. 1.6 kilometres. This thing is now bigger than this board. Am I going to see it? Of course I'm going to see it. It's going to be instant. There's not going to be a time delay. In fact, we could keep, they say, going till we get to the moon. To the moon. And there's only a what? A 1.3 second delay. So how big would something have to be, right? And you can just keep going a distance, right? And this will keep getting bigger and bigger. When is there a delay? When, I mean, it's going to get so big, but when does it become invisible until it starts traveling towards me and I see it? It's illogical. They say it takes 8 minutes and 20 seconds for the sun's light to reach us, all right? And I always say, okay, so if it was turned off, right, and somebody switched it on, because that's what they're saying. That's what they say. They say there's a delay. When we look at Saturn, it takes 1 hour and 20 minutes for the light of the sun to reach Saturn. So when we see it, it's already moved. They say 8 minutes and 20 seconds for the sun's light to reach us. They say that when we look at the sun, if you were stupid enough to look at it for a long time, when you look at it, the sun is actually already 8 minutes and 20 seconds further ahead, because we're seeing it where it was rubbish. And that is what they say. So don't start throwing, oh, it's photons now and it takes 8 billion years to travel from the core of the sun. That is not what we're talking about. We're talking about, they say, the sun that we see was 8 minutes and 20 seconds ago. All right, it's moved. we're seeing old light. So if we're seeing old light, the sun always in yellow, even though it's white, alright? So I am so far away that I cannot see the sun, alright? I'm on Earth, and I'm looking in the sun's direction, but it's off, alright? It's off. Somebody switches it on. You're telling me that I wouldn't be able to see it immediately, right? So when exactly do I start to see it as the light comes towards me? Is it 8 minutes and 20 seconds, it slaps me on the face? Or am I not going to see it when the light's closing in by the moon? Or when it's the distance of Mars, am I not going to see it like a headlight or a motorbike lamp coming? A headlight, a single headlight? It's illogical. It makes no sense. When does a pair of eyes start to see, if this is 150 million kilometres between the sun, right, and Earth, and there's a pair of eyes looking for the sun's light, when exactly do the eyes see the sunlight? What? When it's right on top of him? It's illogical, it makes no sense. You'd see it as soon as it came on. Wouldn't you? Why wouldn't you? Because it takes 8 minutes and 20 seconds for what? Photons to arrive at your doorstep? It's illogical. It's illogical. It's rubbish is what it is. Sun's light is absolute. Bloody ridiculous.